Hi, I'm Anders Liljeholm here at the Oregon Museum of Science and Industry, and I'm joined by Jim Hutchison from the University of Oregon. What is your area of research?
My research areas are nanotechnology and green chemistry. Green chemistry is an area of chemistry where we try to design new products and processes that are more sustainable and better for the environment.
How can nanotechnology help us have cleaner and cheaper energy?
Well, I think there's a few ways that nanotechnology can help to solve our energy problems and benefit the environment generally. One of those is in the area of nano-enabled solar cells. We've been interested in more highly efficient and cheaper solar cells for a long time, but the level of efficiency has sort of plateaued at this stage, and the cost is still relatively high. Nanomaterials, which can be produced rather cheaply, may be the answer. They may be the answer because, first of all, they're highly efficient at absorbing the sun's energy. They can be used to separate the charge to give us electricity, and may be useful in production methods that are very cheap. So unlike the more conventional semiconductor-based solar cells, we might be able to produce these solar cells at a lot lower cost, using things like printing methods, like an inkjet printer, to actually fabricate the solar cells. This would make it much cheaper, and it would be a great way to harvest the abundant energy that the sun provides.
How else could nanotechnology help us with our energy problems?
Well, I think one thing is producing energy, but another aspect is you have to be able to store it. A variety of different approaches to energy have been used. For example, there's the idea of a hydrogen economy. One of the big challenges with hydrogen is how do you store that hydrogen in a safe way and have enough capacity, for example in a car, that you can travel a reasonable distance between refilling the tank on your hydrogen car. Nanomaterials with their high surface area may be one of the approaches to carrying out that hydrogen storage. Another storage approach that involves nanotechnology might be batteries. And again, if we produce electricity through solar, that electricity isn't a very useful transportation energy source. We need to be able to carry that in a vehicle. So batteries are one of the approaches to doing that. Nanotechnology may allow either the production of higher capacity batteries, so we can store more energy per the weight that each battery possesses, or we might be able to do something really exciting, which is to rapidly charge batteries. So instead of having to recharge a battery of an electric car overnight, we might be able to recharge it in 10 minutes.
How long will it take for some of these ideas to become products?
These batteries that can be charged very rapidly are already being commercialized. In the solar area, there's a lot of research going on, but so far we haven't seen that breakthrough that will allow the production of very cheap solar cells. My guess would be that will be in the next 5 to 10 years.
What are the possible downsides of nanotechnology in the environment?
What we know for sure is that if we are able to develop nanotechnologies that provide us with improved energy collection, say from solar energy, or better storage, that's going to be good for the environment because it will reduce our dependence on fossil fuels and other non-renewable energy sources. So we know that part's good. So the question is, will the new properties of these nanomaterials pose any unintended harm to the environment or human health? The harmful effects that people anticipate nanomaterials might present involve some simple things like toxicity. Will the material be poisonous? The hazards of nanotechnology that might lead to toxicity, have to do with the unique properties of the nanomaterials. And for that reason, we can't necessarily predict those possible harms. We have to study them. Other harms besides acute toxicity or the poison nature of the materials might be bioaccumulation. Bioaccumulation means that the material doesn't degrade as most chemicals do, but actually accumulates in the tissue of humans or animals. What the problem with bioaccumulation is that the material might not be hazardous on a very low level, but if it accumulates to a high enough level in the tissue, then that might cause a harm.
Are there any different risks when you go from researching in the lab to manufacturing a product?
When we think about the environmental implications of nanotechnology, we have to think about the process of making the material, not just the inherent hazards of the product. So the process needs to be greened as well. Green nanotechnology can provide that opportunity and provide us with solutions that allow us to convert the basic raw materials to the product in a way that's efficient, eliminates the use of hazardous substance in the process, and eliminates the byproducts that might be harmful from the process as well.
Thank you very much.
You're welcome.